Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe what's meant by an exothermic or an endothermic reaction. You should then be able to draw energy profiles showing exothermic and endothermic reactions. And finally, you should be able to describe what's meant by the activation energy for a reaction. Let's start by looking at exothermic reactions. I'm showing you an exothermic reaction here. This shows wood burning. Now, the key fact about exothermic reactions is that they transfer energy from the reacting molecules to the surroundings. So that means that in exothermic reactions, the temperature of the surroundings increases. In other words, the surroundings get hotter. Now, we've already seen that combustion, in other words burning, is an exothermic reaction. Other exothermic reactions include certain oxidation reactions and neutralization. It's worth learning these examples as they could come up in your exams, and we're going to look at all of these reactions in more detail in later videos. Now, scientists represent the energy changes that take place in reactions by drawing an energy profile diagram. I'm showing you here the energy profile for an exothermic reaction. The first thing to notice is that the products have got less energy than the reactants. That's because energy is being transferred from the reaction to the surroundings. The difference between the energy of the reactants and the energy of the product tells us the energy that's being released to the surroundings. So I'm showing you that here. In the exam, you could be asked to label an energy profile diagram showing the energy change. Now, exothermic reactions can be very useful, and I'm showing you two uses here. We find exothermic reactions in hand warmers, and we also find them in self-heating cans, for example, containing food or drink. Okay, we're going to continue now by looking at endothermic reactions. Endothermic reactions take in energy from their surroundings. So in the case of endothermic reactions, the temperature of the surroundings decreases. In other words, they get colder. And a good example of an endothermic reaction is thermal decomposition, which we look at in a later video. I'm showing you here the energy profile for an endothermic reaction. As you can see, the products have got more energy than the reactants, and that's because energy has been taken in from the surroundings. The difference in energy between the reactants and the product tells us the amount of energy that's been taken in by the reaction, and I'm showing you that here. Now, if we look again at the energy profiles for both exothermic and endothermic reactions, we can see they've got something in common. In both cases, the energy rises to a peak, and I'm showing you these here. This is called the activation energy, and we're going to look at that now. The first key idea is that reactions can only occur when the particles collide with each other, and they have to do that with sufficient energy. The minimum amount of energy that particles must have in order to react is called the activation energy. Now, you could be asked to represent the activation energy on an energy profile diagram, so let's look at how to do that. The activation energy is from the reactants to the peak of the curve. Here's the activation energy on the exothermic energy profile. And this shows the activation energy on an endothermic energy profile. Remember, you'll find plenty more questions on exothermic and endothermic reactions and on reaction energy profiles in my revision workbook, and you can get that by clicking on the link above.